I was just saying that. So I'm connecting from Barcelona, and you are connecting from. If you're willing to
And
disclose your location.
yes, absolutely. No, happy to be here. Thank you for Katz and for inviting me. Float based in Rotterdam, the Netherlands.
Awesome, brilliant. So let's get this show on the road. So I told everyone that we are going to be talking about collaborative technologies and talking a little bit about how we apply that collaborative technology for Dunea. Right. So, first and foremost, we just wanted to set the scene, right? So, thinking about the water sector, if you ask some people, it's gently dragging along. I like to think that we do have our fair share of new technology inside the water sector, and if anything, it is crucial, right? So, water technology is crucial for being efficient, for uh, being productive, but also to be able to provide water to all the consumers, safe water in a timely manner. So we want to make water technology accessible. We want everyone to have knowledge within the utility to be able to perform at their best, right? So not only from an organization and personal performance perspective, but as an organization, right? So we want to make sure that everyone has all the context and all the knowledge they need to service and to provide water to the maximum number of people in a safely manner. And the way what we identified is that obviously the water technology was not accessible. It was siloed, and often operators, the people whether in the ground or in the office, but are doing daily operations, are lacking resources, right? So whether it's financial resources or whether we're talking about hardware, software, and just generally speaking, or people, but just generally speaking, resources, right? And so all this together meant that right now and for the future, what challenge our water sector, our water industry needs some assistance, right? So again, like the idea is really to provide that digitalized, sorry, utility, right? So bringing and all the digital changes, new technologies within those utilities for a purpose, right? We're not digitalizing our utilities just for the sake of it, right? We want to really opt to provide an optimal service, so optimize that water supply with the right pressure and quality, right? So making sure that everyone is getting their service level as long as constant as possible, and that we do that in an efficient manner, right? So we don't want to waste any drop of water that we don't have to, right? So really minimizing that non-revenue water, reduce the any kind of workload that we would have on our teams, boots on the ground or in the office, like I mentioned earlier, but also from an energy cost, right? So how can we optimize our use of the energy that we need to operate our networks. And so all of that bringing together, allowing us to have more resilience, right? So being prepared not to any emergency like climate change, but also organizational change, right? So anything that might be unplanned, if for example, like some of people in my company like to call it the silver tsunami. We have a lot of people that are going to retire in the coming decade, and so making sure that all this information is not only in the engineers or operators' head, but actually it belongs and stays within the organization. That if people are not only retiring but just moving to a different organization, that knowledge is not lost, but actually survives them within the organization. And so the way we do that inside Kitium is by providing that digital replica, right? So being able to visualize this water supply network within an interface that is easy to use. And so we'll talk a little bit more about that. But so the next step is going to be connecting to line data, right? So we like to have a three pronged approach, and so the first one, like I mentioned, is really the visualization of the existing data, usually of the infrastructure, then connecting to that live data to make sure that we understand what's happening here and now, right? I talked a little bit about emergency responses and in order to weather any kind of emergencies in an efficient manner. So that's another layer that we're bringing onto the table. And finally, right, so the cherry on the top is ideally if we have some sort of AI. So in the case of Keychim here, we have an AI assistant that allows the user to be guided, right? Whether the user being either the operator, the engineer, and so on, to be guided by the AI assistant and to be uh, allowing and um, allow the user and to be guided by the assistant. Sorry, I'm repeating myself, losing my words. But also to ask for recommendations, right? So, what should I do in my network if, or in the case I am right now, can you recommend X and Y? But also, as you can see here on the screen, I don't know if it's completely clear, but you can ask and interact with the assistant to perform actions directly inside the network, right? So, being able to create shutdowns like we're seeing right now on on the screens, or just to ask for reports to be created, or any kind of digesting information. As we all know, AI can do pretty well. Um, and so that's the journey, right? So it's like going from data onto insights, right? So through those three steps that I've just mentioned. And so what we're seeing right now, right, is an esquisse of the network with some live data coming through. Everything is green, so everything is hunky dory. We can see the model accuracy uh, popping up into the close to 100%. So that's all fantastic. And so that's but that data doesn't get into KTM without companies like Arians, right? So Float IoT. Uh, is a great company, right? That we love, and so we really happy to have a connector into their system and to be able to visualize and use that information for to go from data to insights. And without further ado, I'll leave Harian to tell you a little bit more about Float IoT.
No, thank you, David. Thank you for that nice introduction and setting of the context. And in essence, um, that's I think why the partnership is there, because you don't only love Float, Float also loves Kitchen. So that is good. Is because both our companies are very much aligned in this overall quest for water utilities to digitize their water systems, their water networks. You have the brilliant software. I hadn't seen the AI before, but seems like a really strong, I wouldn't call it even a feature. I think once it's there, it will be very helpful. And there's a lot of magic in the kitchen platform, so it will help to bring that out. Where Float comes in is we bring the physical, the hardware that enables actually the data to be able to do the digitization. So that's why that marriage, that partnership between our companies works very well. So as said, Float IoT based in Rotterdam, Netherlands. We were founded in 2017, and with the idea that we initially it was doing something with IoT, doing somewhere with hardware and software to help water utilities. And now, indeed, what we say, we help water utilities to digitize their grids. It is, of course, with the main purpose often to reduce non-revenue water or reach energy efficiency optimization, and we do so on a global scale. So we do projects all over the world, where we initially very much had our initial traction in the Middle East, where you have the water scarcity, where you have a lot of the problems on the availability of water. Now and more, our products and solutions are being used by water utilities worldwide. As it states here in the bullet point, I think it's very important to also share that we have a mother company in the form of EasiaSoft. which is a UE-based company that very much focuses on the smart energy side of sustainability. And with them, together with them, this transaction was done last year. We've really now found a way to to have more people see our company and take advantage, take benefit of our products and solutions. So that was a general introduction. I am the type of person that likes to go into the technology bits and pieces. So I'm happy with this slide. When we at the very first moment when we started Float, we had one of the Dutch water utilities coming to us with the request whether we could connect pressure sensors to their lines, and whether through a combination of battery optimized technology, IoT communications that was just coming up around that time, we would be able to build a sort of underground solution. We tried this. We tried our very best. It was a combination of different companies working together. And to be honest, it was one big disaster. It was either the pressure sensor wasn't working, or the communication was failing, or the enclosure was leaking. It was it said 2017, 2018, but it proved to be a very valuable lesson. And this is also why I always emphasize to the people on our team, to our partners, but also to our customers, that it's very important that you always keep on trying to innovate and you learn from these mistakes. Often people claim that they find it important, but then in real life, if they start testing and it doesn't work as they expected it, they don't see it as a lesson. And I think this product is a valuable lesson that if you persist and you continue, it will help you to learn from earlier mistakes. So all the learnings that we had from that initial have been converged into this product that we call the smart handle. Is it possible for you to zoom in a bit on the slide or not, David?
I don't think so. Sorry.
Oh, no problem. Then for the people that are handy enough with their browsers, you can zoom up a bit on the diagram at the top right corner there. What you see there is as said, the product, as we call it, a smart handle, and it helps the water utilities to install in a very cost-effective way. Pressure sensors could also be other sensors, but mainly being used for pressure applications on their lines. So you have at the bottom, you have your pressure sensor. This is then connected to, I would call it a bit like a shower hose almost, to the communications module, which is then placed very near the ground level to optimize the reception for the communications. It's all battery operated, of course, so we have to be very mindful of the conditions that you have with your network. So also the antenna itself, it's placed at the very much as high possible in the installation. Another interesting element of this design is that we have incorporated a diving bell into the design. In the Netherlands, where we have areas where we are 7 meters below sea level, it's very important both for the rain, but also to protect against the water ingress from your groundwater rising, to make sure that none of the water will reach your electronics. So for this, we have the diving bell principle, which in essence is the same. But what you also notice, if you put your glass upside down in the bathtub, that you don't get any water in there due to the air chamber. We've had this in the field now with Dunea for almost a year. I think the initial installation was July last year, and we've been very excited of what we saw, what we've seen there. It has proven to be very robust, which means we don't get any downtime. We don't have any issues with water ingress. As said, everything is functioning as it should. And another important element that to point out is the fourth bullet point. I was there in the initial installation of these sensors. It took at max, I would say 40 minutes, and in most locations around 30 minutes. That goes from opening up the ground to actually doing a hot tap fix, so you don't have to bring down the line to place these sensors. and then closing everything off and starting operations. So that was also it's been proven to be a very effective design. I think this is your slide, David, but I'm also happy to tell a bit about this one. It's a so what you really see here is indeed this combination. I think that what I started here is this marriage that you have. So the sensors enable the eyes. Um, where the water utilities and David already briefly touched upon this, is that water is still is seen as quite traditional and not as innovative as, for instance, energy. I do start to see whether that is at the exhibition, whether that's at the Catchian type of products, that more and more innovation is taking place, and not just the innovation in the form of it's piloting, it's actually going into production. And that is very good to see. It's a hard requirement. It's not out of luxury. We really need to understand better how these water systems work to be able to optimize their functioning. And that's what you see here. I think this is one of the a prime example of various forms of innovation working together. Where we provide the eyes, the eyes can only observe a data, or even though, so in, for instance, we collect around 1 minute pressure points, so 1 minute interval pressure points. Although that is a lot of data, and you can look at it and it will give you zero insight at all. It's really when you start and you give your user the ways to analyze this and to visualize this, where the actual insights come, and that's what you then have with the Catchian platform. One of the elements where we've been very excited about, there was a time when you would go to a customer and you had certain new developments or certain new data types that you would like to integrate with. Everybody was very much concerned about the integration part. How can I get this data into my infrastructure, into my applications? Uh, well, without overdoing it, I think the two of us, our teams, have been capable of doing this integration in a matter of days. And that's what you see when you get new types of technology into the field with the proper interfacing APIs. So that was also very good. You have anything to add to that, David? You're muted. I think that were you.
Working together. Yeah, I think that working together has definitely been easy, right? When we build that seamless integration, and I think that ultimately the customer is the beneficiary at the end. But it's true that now that kind of like seamless integration, right? So you mentioned collecting information every minute, and my understanding is that we receive it every minute also, right? So which is like very, very, very powerful, right? Uh, so having this data into KTM at a high frequency also allows for very quick time to response from potential time to response for the utility, right? And so we're not talking about technology for the sake of technology and for just being integrated, right? We're really focusing on the value to the customer, and so that comes through collecting the data, transmitting the data, receiving the data, um, and in the end, providing it into a user-friendly platform, right, uh, for for the user. And so I think that with this partnership, we managed to do that very very well, and to provide Juniors with all the information they need when they need it, almost to say at the instant, right? So everyone knows that one instant is different type of measure depending who you talk to, but it is genuinely in an instant, right? So it's very beautiful to see all that coming together. And so we talked about ATM, we talked about Float IoT. Just wanted to give you a little bit more context about Dunea, right? So Dunea is a water utility in Netherlands, right? So the name actually Dunea comes from the dunes where the water is taken, or most of their water, or I don't want to say most, if maybe it is not, but that a major part of their water is coming from. And so they have some fascinating technology. I invite you just to Google Dunea and innovation just to see what they're doing with those dunes and understanding how and what water they're grabbing from where. They obviously, for anyone who knows a little bit the area, so they cover the city of The Hague and all this area, so quite densely populated, right, area to provide water to, just like any water utility, right? So the infrastructure is aging, right? So distribution network is not getting any younger by time passing by, and so that area, which is half urban, half uh, under the sea, I understand, behind the dunes, is growing in number of customers, right? And to monitor all that, Dunea had only 25 bulk pressure meters, right? So if the utility was there, he would just say just about that having trying to understand how your network behaves with only 25 bulk pressure meters is kind of really hard, right? And that's where float IoT and KTM come in, and we need to have that. And in order to do that, we focused on a. We started with a DMA for that proof of concept, and that's been. They started by building the DMA since 2017. It's about around 7,000 connections. Feel free to tell us in the chat how big are the DMAs where you're connecting from. Feel free to share that in the chat or to put that through the Q&A. So Q&As are on the right hand side of your screen. You should have a little box with a question mark, and you can ask a question there. We'll address that towards the end. And so to give you an idea in terms of annual consumption, also it's like over 1 billion cubic meters. And so the idea for that focus and for that proof of concept, right, is the real-time leak detection monitoring, right? So giving visibility as much as possible inside the network, um, and through monitoring and through understanding whether and where and when there are leak in the network. I don't know if Harian, you wanted to comment a little bit more about that proof of concept with Junia?
Yeah, absolutely. The village of Nieuwrijk aan IJssel in itself is already very special. It is indeed close to the lowest point, so the 7 meters is actually there. It is typical Dutch, I would say, and it was a proud of my family because actually I I never knew why we selected this village, but my mother's side of the family had their business there, so it is a bit of a it's a bit of a gem, a hidden gem, I would say. No, what happened? Actually, Dunea has been crucial in designing this solution because what you can often get if you put a lot of smart engineers into one room without seeing the actual application, you start to over-engineer. And Dunea has been involved from really from the get-go to make sure that everything that we do there is very much required in the field. Yeah, I'm not sure if we have someone from Dunea in the uh, in the attendance or among the attendants, but I keep on thanking them, so I do so even if they're not around. But indeed, the idea there is because they have the DNA itself. I believe for this is quite standard for their Dutch layout, and why they also like it as an example and as a proof case is because they have multiple feeds into this DNA, and specifically for leakage localization, which is one of the reasons why we are implementing these pressure sensors. It's proof a very good design. Another important reason is that they have, as said, it's quite small there, but they have a few, and specifically one very large industrial end customer there. And that end customer, in certain moments of the day, I get somewhere in the morning, when they open the tab to clean the facilities, they take up to 65-70% of the overall consumption of this village. So this has an enormous effect on the pressure. And to be able to understand the effect on the pressure, and not only the complaints for the customers, because those customers have been there in the past, this has been very helpful. Another element where this has been very helpful is, I'm not sure if I can name the specifics, but they have done substantial changes in January on the feeding system, so where they get the water from. And to be able from December to January exactly understand what those feeding changes have resulted in the pressure profile over their network has been also good for them to understand what those design choices have made for their end customers and how to optimize from there. So that is, for a multitude of reasons, the proof of concept. Actually, the word proof of concept, we've gone way beyond that in my view. But okay. So one of the other things, I think, indeed, what is a very important point, there's a lot of I wouldn't say misunderstanding, but lack of understanding still about how many sensors do you need in these kind of networks. And the idea has been to, in this case, so you have 7,000 end connections, and we've installed 20 pressure sensors, and we've been collecting a lot of data. We've gone normally to 1 minute, but at one stage we even went to 15 seconds of collecting. And that is to see whether the Katium platform could still visualize that data. Well, it did. So that was good, but also to see how much value is there in going into more granular amount of data. And so I think that is also has been very crucial. And I think we covered most of this slide.
Brilliant.
So takes up to how it went, and I think this was a very good contrast to the earlier pilot POC that I told you about, which we did at the start of Float. This was just genuinely a very smooth experience. No issues on the hardware, no issues in the integration. The visualization in Katium was very strong. We did a range of fire hydrant tests where, in set moments, we opened the fire hydrant to see whether we were able to pick up on the leakages, on the simulated leakages. And also there, we could see that the Katium platform was indeed able to detect that the flow profile was not as it should be at that specific moment in time. And it was actually capable of picking up leakages at a very early stage. We are working on even further improving the actual localization of the leakages, because of course, it's one thing to be able to detect, do I have a leakage in a DMA? The next step with these sensors in place is, of course, to be able to localize there. There we've seen if I say mixed results, we've seen instances where we've been able to localize leakages within a couple of hundreds of meters. And I believe there is reason to believe that we can even improve on that. By, yes, installing more sensors, but also in overall, we have a certain data set now available that we haven't had before, and I think we can further optimize on that. And that's also the reason why we said, okay, it's been so smooth, so successful so far. How do we continue? How do we do the continuation of this pilot? And this is indeed by focusing more on how we could further improve on the localization, and also to start to assess even better how many, if you go to a overall wider implementation for Dunea, how many sensors would be required. Give us, I think, another 4 or 5 months, and we should be able to also give more feedback on this. But again, yeah, it's been a very successful effort so far. I'm looking at the Q&A at the same time, and at the chat. I don't see any questions. So either we're being very clear, David, or we're being very boring. You may answer that one.
Yeah, I don't know, but yeah, I just wanted to wrap up right with the last slide, and I see that trying to give people the opportunity to think about a question, and to don't hesitate to ask. There are no silly questions, um, and so we would be very happy to answer any of them. Just as a reminder, you can ask them on the right of the screen. You have a box. Well, you have a box for the chat, and I think you have a box for asking question, which is with a question mark. So just to wrap up a little bit, right? So um, I think that we clearly showed how our partnership was definitely useful to Dunea, and really focusing on trying to get those three key pillars across, right? So what do they care about? What do a utility want to do? And how can we address it, right? So for us, it was really focusing on the service, the efficiency, and the resilience, right? So having a resilient utility means that the utility right now and in the future, regardless of what is happening, whether it's climate change, whether it's electricity stopping in the whole country, being based in Barcelona, I can tell you how it went a little bit. If you have any questions about it, ask in the chat. Um, but also efficiency and service, right? So we want to be able to provide water to every single customer as much as possible, with the minimum amount of interruptions, right? Those customer minute lost um, are precious, right? And so we want to avoid them at all cost. And so in order to do that, we also want to reduce the number of water that we're potentially wasting or that we're losing to the environment, um, to any place that is not our customers' taps, right? So we want to do that in an efficient way, in a way that also preserve us from being too energy intensive, right? So trying to identify whether there are bottlenecks, whether it's in the networks, in our processes, and so on, and all that comes down to digitalizing our utilities, right? And so um, for that, I just wanted to thank everyone. And if again anyone has a question or two, I see that we actually have a couple questions. Um, so we got one from Oliver. Um, you on great presentation. Thank you. You have mentioned 1 second and 15-second sample times for a handhold. Has there been any indication of surge events being recorded in the network with this level of data sampling? Harian, I think this one is
Yeah,
for
absolutely. Good question. Because we're looking at those water hammers there. Then I think that's where the question is targeted at. And yes, most definitely. Amongst others, around the customer that I was referring to, the large industrial customer, we were able to pick up these water surges indeed. Of course, you're still looking at 15-second, 1 minute data. So it's not sufficient to do a, let's say, a transient detection or a transient modeling. But the surge itself, most definitely, we've picked up on numerous occasions.
brilliant. Thanks. Thank Harian. I think that there's one that's coming from me. I see that there are two places where questions are dropping by. So in the chat and in the Q&A. Keep them coming. So one is, does the platform have any sensor placement capabilities? Yes. So pla- the platform is a platform per se, right? So we do have plugins, and so one of those plugins that has been developed is for pressure sensor placements, right? So really trying to find where are the critical points in your network where you can put your pressure sensor. And really the idea is to give you a certain number of options and solutions for you to take the decision that gets you best, right? So there's going to be two different criteria. One is like being able to identify um, whether there is or not a pressure drop and a leakage. And the other one is being able to understand where is it, right? So how does the network of sensor can be placed in order to give you the optimal uh, location understanding, right, of where the leakage is, and that is based on some constraints, knowing like taking into account the existing sensors, pressure sensors that are there, and also the number of sensors that you'd like to have to place. Um, so that's for sensor placement capabilities. I don't know. We have a question from Hisham that is about Dunea's network project and then whether the total length of the network. I don't know if you have that on the tip of your tongue, Harry. And I don't recall, to be honest. Um,
No, I'll be very frank. I tried to have it at the tip of my fingers. So in the meantime, I was WhatsApping our contact at Dunea to ask that question. So for now, I don't know. But if he answers swiftly, then I can share.
Awesome, brilliant. Well, we'll keep this one in the bank. I think that we have another one which is about the pressure sensor, and so the question is how does it work, right? So does it come in contact with the water or just senses the pressure from the pipe?
Yep. No, but I believe quite a few of the people in the audience will know the principle of a hot tap, where you place the saddle on the tube, and that's where you then place the pressure sensor. So you have a minimal contact of the water with the sensor.
Brilliant. So the benefit for that being that obviously we don't have to drill through. Is that correct? So
So you,
minimal need to actually disrupt, right, the water supply, whether it's to the neighboring area or uh, or even potential contamination, right?
yeah, so you do the drilling, but the drilling is done in such a way that you can keep the line in operation. Uh, so that's what they call then the hot tab. Another benefit of the method that you have here is that you also get temperature readings, fairly accurate temperature readings, which in environments like the Middle East is of a lot of interest because there you would like to understand what is the temperature of the water, of course, for multiple regions. And also in the Netherlands, this is getting more and more interesting because we have quite a lot of the public heat networks now being placed in the ground. And there is some general concern there about the effect of those heat pipes on the water, and of course the quality effect that might have. So you have a combination of the pressure and the temperature of the medium.
Brilliant. Yeah. And for being there at the receiving end of the data, it is true that we've seen like a wealth of data information that we can tap into, just like you mentioned, right? So temperature, battery levels, and so on, and so it's quite nice also to be able to have access to that information, to that data, sorry, to provide more information to the user depending on their tasks. I'm being reminded that please feel free to click on the bottom of the presentation where you can see this collaboration live, where you can access directly Keychim.com and request a demo. If you have any other questions, please feel free to ask it there. I think that we're probably going to be closing unless we have any last minute questions.
So
I
some
see
more
one.
questions still.
I see one from Jermaine. Will the platform work on intermittent supply network? So I want to say yes. So the short answer, and for anyone in sales and KTM that listening to this webinar, so I say yes, right? So yes, it will work, right? So in the sense that if there's no using a pressure dependent model in the back end, right, and setting that inside KTM, basically will show where there is water and where there is not water. What you cannot see is how full or the charging of the pipe like you would in um, a storm model or something like that, right? So, hopefully, German, that answers your question. But I'd invite you to click on the link below, and so we can get in touch and show you exactly what are the capabilities when it comes to intermittent supply network. Um, I'm keep going between the chat and the and the Q&A in order to not lose any question. We got a question about what is the leakage detection time? So I'm not too sure what you're referring to. I don't know if Hargan, you have more insights on that. But how long does it take to determine that there is a leakage, if that is the question? So it's fairly instantaneous, right? So
It is.
we
Yeah, absolutely. Yeah. So I think indeed the question that you have here is what you have. There's various ways, of course, to detect these leakages. What we've observed in the Katja platform is on the flow. It runs a model which simulates. It detects a baseline in which it sees it this time of the day what is the normal consumption, and you are able to detect actually the leakage instantly if it is of substantial size. And then, of course, the other element, are you able to pinpoint the location? For the location, this is not so much time bound. It is bound to how many feeds do you have. It is it's a lot easier to pick up and localize the leakages, especially localize them in a single feed fed system. And normally it is once you've detected and then to go to localization, this is done within a matter of, I would say, an hour. And there was also another question, and that question was on the pricing. Pricing always, as always, it goes hand in hand with volume. But that's a bit of an easy answer, and I have promised to myself and David that I would not do those. We've built together, I think, a very cost-effective solution. And the one element that we've also said, yes, it needs to be cost-effective. It needs to be device agnostic, which means, in this case, sensor agnostic. So if you, as a water utility, has certain preferences for different pressure sensors, then the hardware, the communication, and also the platform, of course, can handle those. And we even go to the point where we say, if for a water utility they want to work in a OPEX model, where the investment required to install these sensors would be done by ourselves, and then we would have a model in which you would pay essentially a certain amount of money every month for the data point. So we have various models available, and I think a fitting model for each and every water utility, because in essence, I believe we have been able to provide a very cost-effective solution, as said. To dive into more specifics on that, because I do understand if you need a more specific answer, I think it would be good indeed to use the link below, and then we can always have this discussion in a follow-up.
Brilliant. I wouldn't have answered it better myself. Um, and I think that's all the questions I think that we've covered. So I'm gonna thank you, Harian, and thank you, everyone. Oh, I see that we have one more thing coming. Oh, okay. Coming into the chat, but that's us. So feel free to talk to us. You can reach us obviously through the link below, but we both have LinkedIn. If you want to have like a communication directly with us, I think that we're both very open to have those conversations. So feel free to reach out if you have any question. Thank you for coming. Thank you, Haryan, for co-hosting, and hopefully see you on the next webinar. Bye bye.
Thank you, David. Bye bye.